Okay, so what we're going to do is start with an overview of the frequently made mistakes from assignment 1B. So here were the things I found. I posted this to the mailing, to the Piazza discussion forum, but I thought I'd go through it. And if anybody has any questions, you can let me know, and I'd be happy to clarify some of my comments. Keep in mind that the final submission for assignment 1 is due on Wednesday, and most of you should have very few things to do at this point, but here's some stuff to do. So here was an example of a remove method that was way too complicated. So recall that move really just has to do a few very simple things. After it does a range check, it needs to see if it needs to make any changes to the to slide the elements down by 1, and if so, it has to do that. But this is way too much work, and it's not properly refactored, so it can be simplified. Here, here was an implementation of the iterator method that's also too complicated. So the iterator method should be really, really simple. And in particular, you should not be making any assignments to fields or a field of the iterator object in the iterator method. That should be done in the constructor of array iterator. So that's where that code should be isolated and encapsulated. This code is too complicated. You don't, if you've set up the constructor properly, if you set the field in the constructor properly, you don't have to check all the stuff here, just have to check part of it, so that's too much work. This again is something, please make sure that you simplify your Boolean expressions. You should just be saying, return size equal curve position, or whatever the right check is. You don't need to say if size equal curve position, return false, else return true. That's just too much syntax. You don't need that here. The next method can be implemented more simply by using the get call, which you would get from the array. That's the enclosing class for array iterator. And that'll be the thing that actually checks to make sure you haven't exceeded the bounds, and will throw an exception if you have. So that can simplify things a bit. The next method, so next is a little interesting. You shouldn't need to call hasNext from within next, because the way that iterators work is that you're supposed to call hasNext. So if you don't call hasNext and you call next, oh well, your code is buggy. So two things. First of all, don't call hasNext in next. You should have called that in, you should have done that checking in hasNext. And secondly, next needs to handle error checking properly. So if it turns out that you are exceeding the bounds, then it needs to blow up. And the best way to do that is simply to call get. Here's another piece of code. This code here should be massively simplified by simply calling the remove method that's defined in the array class that's enclosing the array iterator class. So you don't have to repeat yourself. Remember the famous dry principle, don't repeat yourself. Why do we not want to repeat ourselves? What's the problem with repeating ourselves?
It makes code very long and hard to read.
So it's long and hard to read, but what's the other reason?
The more code you have, the more code you have to debug.
Exactly. So if you repeat yourself and there's a bug, or if you want to improve one part of your code, then if you've repeated yourself, you have more work to do to track everything down and make all the fixes, make all the optimizations, et cetera. So it just becomes excessive. And you wouldn't notice that. I mean, if you write a 80-line program like this, it's not the end of the world, but the principle applies to much bigger code. So this was some code that's missing some things, and you need to do some updates to your local state after you remove stuff so that you're ready for the next go. This was interesting code. So I tried to discourage people from using loops. There's sort of one place where you probably have to use a loop, and that place is the replace all method. But unfortunately, this loop doesn't quite get us to where we want to go, because this loop, as you can see, doesn't actually make any updates, doesn't replace anything. It just calls the apply method. So it'll I'm not sure what it'll do, but it's not going to replace any of the parts of the code. Likewise, this is definitely overkill. So this is they're trying to do the right thing by using an iterator. That's usually a good thing. But in this case, using an iterator means you have to call the set method, and the set method does extra range checking, and so it's just overkill, unfortunately. So the best thing to do there are several different ways you could go here. What I did, maybe it was a cop-out, but I just used a regular good old for loop with an index and just kind of held my nose and did it like that. You could also write an unchecked set operation where you could potentially use that. So there's a couple other ways to do it, but the for loop seemed to work fine. This code is also inefficient. It's clever, so don't get me wrong. I like the fact that you're using streams operations. That's good, but this is probably more trouble than it's worth, and it's also using set again, which is going to have extra range checking we don't need to have. This code is definitely way too complicated, so I'm not even sure what it's doing, but it's doing way too much stuff. It's iterating, and it's calling replace all, and it's making an array, and it's doing an array copy. Doesn't have to be anywhere near that complicated. Just a simple for loop with an index will solve this problem quite nicely. This implementation, at first glance, looks good, but unfortunately, it's calling the index of method. You can see right here, index of is being called, and index of is linear, right? So it goes through to find the index. So this actually turns something that should be linear into basically n squared, which is not at all efficient, so that's not a good thing to do. But just because we had to hold our nose and use an index counter loop for replace all doesn't mean we have to do that everywhere. So for each can be simplified by using either a for each loop or the for each method call. Either one is good. This is obviously unbelievably too complicated. So this is a good example of the don't repeat yourself principle, because the code was inefficient and too complicated before. Now it's replicated again, where it's still too inefficient and too complicated. So don't write code like that. It should be very simple. This is some good example of a code. Again, definitely on the right track. This kind of code here, x arrow action.accept x, that can be turned into a method reference. We'll talk more about that here shortly. And use a for each loop instead of an iterator. Again, iterator is not wrong. You're on the right track, but since you're doing a good job, let's go the whole way and use simpler Java 8 features. And then for the grad student version, which will become part of the next assignment for the undergrads, the try-split algorithm is used, as we'll see, to split a big source of data into two smaller chunks. And this is an inefficient way of doing that. Way, way, way too much work. Copies going on and so on. Splitting is much simpler than that. And this case here is close, but needs to handle the situation where there's no more elements to split. For those of you who are doing the splitterators, which the undergrads will have to do next time, the way splitterators work is if you can't split things any further, then you return null. Otherwise, you split it in half in the most efficient way. And we'll talk more about that. OK, so are there any questions about that assignment?